And, oh, and I've closed the slides. All right, so now this is going to look foolish. Everyone say hello to YouTube. Hello, YouTube. How's it going? See, now you're all part of the recording. Isn't that fun? Okay. I don't know, maybe I'll bring a spot mic in next time. Okay. So last time I was talking to you about if statements. We just basically looked at simple if statements. I gave you the overall control structure. So today, I just want to do many, many examples to really solidify your understanding of if statements. And specifically, I want to take if statements that are overly complicated and simplify them. So there's this word in computer science called factoring, which is very similar to the mathematical definition of factoring. So in mathematics, when we factor something, that means you take something and you break it into smaller pieces so that the product equals the larger thing. In computer science, factoring is the same thing, basically. You have some complex problem, and you want to take that complex problem and subdivide it into smaller problems, and then solve the smaller problem so that the big one gets solved. That's computer science in a nutshell, basically, is this type of factoring. I'm telling you this because today we're doing a type of procedure called refactoring, and that is to take code and to try and factor it again so that the overall output of the code doesn't change. So to say that in more simple terms, I want to take code that's written and change it to make it more simple in a way that doesn't actually affect the runtime of the code. So it still should output exactly the same thing on exactly the same input. So a few warm-up examples. If I put in sequence 3 if statements, if x is greater than 1, if y is greater than 2, if z is greater than 3, print hello, how can I simplify this statement? Yes. Yes, I can tie all the if statements together using an and, the conjunction, right? Because I can read these if statements like this. If x is greater than 1, then if y is greater than 2, then if also z is greater than 3, print hello. So you need to note that these are equivalent pieces of code. They look different, so they're not equal pieces of code, but they are equivalent pieces of code because they both do, oh, well, this shouldn't be x equals 1, that should be print hello. So if I change that to print hello, then they will be equivalent pieces of code. So this is definitely more preferable to this. Right, because I can see very precisely what condition has to toggle in order for hello to be printed. Here's another one, and this is a very common this is a very common thing that new programmers write that is unnecessary. So if I define a function called foo, and it takes in an input x, and I say if x is greater than 0, return true, else return false. How can I simplify this? Over there. So you're saying that I should use an inline if statement. So you're saying I should use the if statement that sort of you write on one line, right? I can say return true if x is greater than 0, else false. That is kind of a simplification. You're still using an if statement. It's in the right direction, but I can even go more simple than that. Who in the back there? Okay, we can get rid of the else and just return false, but think of, oh, okay, one more try and then I'll give you the answer. Yeah. Return x greater than 0. That is exactly the answer I'm looking for. Let's walk through this if statement. If it is true that x is greater than 0, return true. If it is false that x is greater than 0, return false. That's just this, right? So when you're working with Boolean constants, be careful that you're not sort of checking truth, right? That's what the if statement is doing implicitly, right? So that's one way you can simplify this. I've already seen something like this floating around. If x is greater than 0, then set y is equal to true, else set y is equal to false. That's a little variation on the slide before. How can I simplify this? Yes? Indeed, y is equal to x is greater than 0, right? Because you're basically saying if true, set true, if false, set false. You can do that directly just by saying set this to the truth of that predicate. I'm going to simplify this in 2 steps. So the first thing I want to do is simplify the condition. If I say If x is greater than y is equal to true, set z is equal to 1. How can I simplify this? By first simplifying the condition. Yes. Perfect. Right? Whenever you're checking a condition, it's checking that it's checking for the truth of that condition. Right? So this would basically be checking if x is greater than y equal to true is true, then do this, right? So you don't have to specify that the condition you're checking needs to be true. That's just implicit to the if statement, right? So that's another typical error that's sometimes made by new programmers. There's one last simplification that we can do, and that is I can just set z directly to the result of x is greater than y. Although maybe this, now that I'm thinking about this, this isn't exactly equivalent. Why is that the case? Right, this is only correct if x is greater than y. Right, I have no rule that sets z to 0. So this would set z to 0 if this was not true. So maybe I'm going to remove this. So this certainly simplifies to this, which does not simplify to, that would make a good exam question actually. So just going to lock that one in. Okay, so here are two blocks of code, right? And recalling the definition of equivalent being gives the same output for all the same inputs, are these two blocks of code equivalent? So I have block 1, which is an if-else statement, or if-else-if statement. So if x is greater than 0, then print A. Else if x is less than 0 and x is even, print B. And block 2 is the same thing, except I remove the condition here. Are they equivalent pieces of code? Take maybe 30 seconds to think about it. And if they're not equivalent pieces of code, you should be able to give me a precise value of x, so that block 1 prints something different that block 2 prints. Think of it this way. If this condition fails, right, then we have to execute this elif statement. So if this condition fails, what can be presumed at this point in the code? That x is not greater than 0. That is to say, x is less than or equal to 0. So these two blocks of code are equivalent, right? Because even though I didn't write this condition in the second if statement, it is implicit that it is less than or equal to 0, because that condition already failed, right, at the first line. Right? So in if-else statements, the conditions carry to the next block, right? So this may be a little bit weird. I want you to go to the labs and sort of play around with this, right? Because it will take a little bit of thinking and struggling to finally get this. But after a lot of examples, you should basically get the point. I'm going to modify this example a tad. I'm going to say, I'm going to replace the else if statements with ifs. Are now these equivalent pieces of code after I make that tiny modification? Why don't we trace what happens when I set x is equal to 2? So let's look at block number 1. If I set x is equal to 2, if 2 is greater than 0, print A. So this prints A. And if 2 is less than or equal to 0, and 2 mod 2 is 0, then print B. So this one fails, right? Because 2 is not less than or equal to 0. So block 1 prints A. For block 2, what happens? If 2 is greater than 0, print A. So block 2 prints A. And additionally, if x is even, print B. So this prints B. So this prints A only, and this prints A and B. All right, so the point I'm trying to make here is that in an if-else block, you can carry forward the conditions. In if statements that are in sequence, right, you can't, right? If statements in sequence are independent of one another, right? So there is a very important nuance between if statements and else if statements, right? In an else if statement, in a block of else if statements, exactly one code block executes, exactly one. In a sequence of if statements, every if statement gets an opportunity to toggle. So it's a big difference. But please go to the labs this week and play around, right? It's going to require some study to sort of fully get this. Okay, so here's something fun. Did you know that the university library has a catalog of old exams? You should find them. They're very, very useful learning material, right? So I actually went and I dug up all the old exams for this course, and I'm going to try to use those examples in class, right? So the stuff that we're doing in class is going to prepare you for your final, right? I went to driving school, and the teacher said, we need to teach you two things, how to drive and how to pass your driver's exam, right? They're two kind of different things. So in the same vein, I need to teach you how to be a computer scientist and how to get an A+ in this course, right? Which may be mutually exclusive types of things. Okay, so anyways, here's a question, right? From the final in 2014, question 1, part D. It was worth 1 point, I think. What is the value of Z after executing the following? Right, so this is a very typical question from your exams where you're asked to trace a piece of code. So two things I have to mention here. One, this is a new piece of syntax that I'm showing you. I don't want to go too much into it, but you can define variables like this. I can define 3 variables on the same line by just saying this triplet is equal to this triplet. I don't want to talk about tuples at the moment. All I want to be able to do is define 3 variables on the same line because I'm running out of vertical space basically on my slides. So just allow me to define variables like this. It's syntactically correct. You can do this in Python. So what I recommend for questions like this on your final is that you actually take these values of x, y, and z and overwrite them here. Right, so you can actually see very explicitly what's happening, but today we're going to be forced to use our imagination paintbrushes. So let's walk through this and see what executes. Did you have a question? Okay. You know what? You think it's 3. Okay, so let's walk through this. So x is 1, y is 2, z is 3. So if 1 is less than 2, so does that trigger? Yes. It'd be better if that was more resounding. But this passes, so we now enter the code. Is if 2 is greater than 4, which fails, so the else gets triggered, which sets z to 6. So z gets 6, not 3. Yeah. Excuses, right? Oh, I didn't actually get the question wrong, right? Because I answered the question that was in my head properly. The answer is 6. Here's another question from a final. Final 2016, question 2, part A. This question asks this. Write me a function which decides admission given the average for a student and the cutoff. Right? So we should return the string except if the student has a mark past the cutoff. We should return except with scholarship if the student not only passes the cutoff, but passes the cutoff by 5. And then we have to reject the student if the student is less than the cutoff. So I'm going to move to my, I'm going to code this right now. So let me just open up this Wednesday code. So what was it called again? Decide admission. Decide admission for average and cutoff. So I believe this is going to take a float and return a string. Something new I'm going to teach you. So assumptions, right? Average is greater than 0 and cutoff is greater than 0. So it's a new thing that you can add to your doc string. I'm not going to write a description because we have one. Let me write decide admission for, suppose that someone is underneath the cutoff. That should return reject. If someone is right on the cutoff, that should be accept. And if someone is well above the cutoff by 5, that should be accept with scholarship. Okay, so, but we had some conditions here, right? So I have to write it like this. And I think this was return reject. This was return accept with scholarship. And this one was return accept. Okay, so now we have to fill in these conditions. So what is the condition for accepting a student? What should be here? Right? So we can't change this code. This is exactly what was on the exam, right? It's saying fill in these 3 conditions, right? So what's the condition for accepting a student? Yes, anyone? Okay. And then what here? Oh, sorry. That makes more sense, right? Okay, so what is the condition for someone getting accepted with scholarship? Perfect, right? Okay, let's check. Just going to call this into the interactive mode. Whoops. I have to fix all of my errors. What's going on here? Okay. Oh, I'm calling the wrong file. Okay, so we have this decide admission, so let's check our examples. 7580. Perfect, right? 7070. Okay, and then I had something like 9880. Uh-oh. That's wrong. What did I do? So what happened, right? So this is exactly the trick on the assignment. We were trying to trick people into giving us this answer. I bet you this was the most popular wrong answer, right? What has happened here? Well, this is correct for students that are above the cutoff. Right? You're above the cutoff, so you get accepted. However, if you have a scholarship, having a scholarship implies that you're also accepted. Right? So this checked that you're accepted and then stopped. Right? So in fact, we have to add another condition here that says and average is less than the cutoff plus 5. Yeah. This was an exam question which said fill in, right? Okay. Follow instructions, right? Of course, like every class so far, someone has raised their hand and said, can't I do it this other way? The answer to that question is yes. Every single time, yes, right? There is a million different ways of writing the same program. Okay, so given that we were forced to write it this way, it's so that we could catch people making this problem. So that being said, so there is the answer, except that I made a mistake as well. This is a redundant condition. So look at the slides and think about why that's a redundant condition. But I have the answer there. But I want to have a follow-up question to this, and that is, let's simplify the code now using all of the suggestions that you guys had. So how can well, there's one suggestion already that would simplify this code. I can take that off, and I can simply swap these. Right? So first it checks that, do you get accepted with scholarship? Failing that, do you get accepted without scholarship? And failing that, you get rejected. Right? So you can simplify your code simply by switching the ways that you check conditions. There's another way that I can write this. I'm going to write it like this, right? So if your average is greater than or equal to the cutoff, then this is for sure you get accepted. For sure accepted. So I can check furthermore if the average is greater than or equal to the cutoff plus 5, in which case I should return accept with scholarship. And if that fails, I just return accept. And if all of that fails, I just return reject. Right? So you don't need if statements to explicitly branch you. Right? You can say if on success, do this, otherwise just continue. Right? So here's another way. Oh, recturn. Jeez, that sounds like something you have to go to the doctor to get corrected. So there you go. Right? That's another equivalent way of writing it, exploiting the fact that returns are going to escape from the function. So I wrote the answer there. So I have two questions here. I'm going to ask you to do one of them. So, this one I'll make you do at home because it's just a lot of arithmetic and you should work it out with paper. So take this one. This is the question from Final 2015, question 1, part F. So you should for sure be able to, do this because these are questions directly from past year's finals. Right, so it's a good way of checking if you're up to speed. Yeah.
About the final exams, there are no mark schemes or
Yeah, but like, you should count yourself lucky that even some of the finals are available. Like, usually we don't provide finals from past years. This is like a University of Toronto Mississauga policy, right? So. Should be thankful for that, right? It's very, very difficult finding old exams usually. So I'm happy to solve any problems from the finals in my office hour with you guys. I'll give you the answers to anything, basically. I don't really care. So do this one at home. The answers are there. Let's try to do this one because it seems a little bit more tractable in the time that I have. So what is the value of total after this code runs, right? And we're going to go through this. So given that total is 0, first is 4 and second is 0, why don't you guys take, I don't know, 30 seconds and try to work this out. And then I will give you the answer, which I actually don't know. So I'm gonna walk through it like you guys. I'll do a dance while you guys think. First person with the correct answer gets an A+, but if your answer is wrong, you fail. All right, you in the blue? 0. Okay, so we have the answer of 0. So let's determine the fate of the person who answered. Okay, first, second, total first and second. So we're just going to go through here and just evaluate this as the computer. So if 4 is greater than 5, so this false, so this gets skipped. So we go into the else statement. If 4 is greater than 5, which is, so this gets, which means all of this was skipped, which means total is A+ for you, sir. You may leave. Total is 0. Okay, so the last thing I want to do today, so don't move, okay? I'll tell you next time we're going to start doing loops, which is going to be very exciting. And I'm going to show you loops. No, I have like another question that's going to take 10 minutes, so don't pack. Right? This is why I was hesitant to show you the slide in the first place. But I'm going to show you loops by introducing you to some sort of more advanced set theory. It's going to be less complicated than you think. I actually find that this helps everyone conceptualize looping, with the bonus of preparing any of you who are on a math track for what's coming there. So I have a huge piece of code that we're going to try and simplify. Oh boy. Ooh. Okay, so it's a big piece of code. We're going to go in and we're going to try to simplify this, okay? So I'm going to do this by writing in assumptions and deleting things. I'm going to overwrite this code. So it is critically important that you stop me if I make a mistake or you don't understand something. Because going back, believe me, this was a disaster in the class before. So let's look at this. I'm just going to make this a little bit bigger. We'll worry about what's at the bottom later. Okay, so if I get to this part of the code, oh, sorry, there seems to be, give me a second, 1, 2, 3, 4. Don't know how that happened. 1, 2, 3, 4. That's better. Okay, so if I get to this part of the code, what assumptions can I make if I'm here at line 3? I can assume that x is greater than 100 and y is greater than 0. Yeah. Okay, so what does that mean about this statement? So if x is greater than 100, what does that mean about this statement? It's true. What about this one? This is also true. Okay, but this is an or and this is a true, so what does that mean about this? Whole thing is true, which means this is actually an else statement. Right? An if true is just an else, which means this else is pointless, right? Everyone still with me? Okay. So what can we conclude about this if statement? If the statement triggers, it prints, well, it returns A, and if it doesn't, it returns A. So yeah, then I guess this is sort of pointless. This is just return A. Okay. I'm at line 5 now. What assumptions can I make? Okay, so I'm going to make this very explicit. We're here, so it must have been not the case of that this condition. So not the case of this condition was what? So this is x less than or equal to 100, or y is less than or equal to 0. See, I didn't teach you all of that logic for no reason. Okay, and it is the case that what? That this condition is true, right? Savvy? Okay, so let's use these conditions and see what we can simplify here. Well, if x is equal to y, return A. Well, okay, I don't know anything about that. If x is less than or equal to y, and x is greater than or equal to y, return B. How can I simplify this? What is the only, yeah, I heard the answer, but I'll ask a question in order to make everyone understand. What is the only case where two numbers can be both less than or equal to one another? They both have to be equal. So I can replace this condition with this. Okay, but if x was equal to y, then this would have triggered. So this is pointless. That will never work. What about this? If y is less than x and x is less than y. Yeah. This statement is a contradiction. Yes, so this is just false, right? Well, if false, that just means the else is always going to be triggered, right? Okay, so this I can just remove, right? So now we have, now I've broken my system. Now we have this, if x is equal to y, return A, and if that fails, return A. So I guess this is all just return A. Okay, so let's do the final one here. Oh, I shouldn't have. So I'm just going to collect this. So now we have this, which was the not of the first one. And then we have also not of this. Right? We have not of this, which ends up being y greater than 0 and x greater than 0. And both of those conditions are true simultaneously. So what can I figure out here? So x is greater than 0. Oh, y is greater than 0. So this is true. Y is less than or equal to 0. So this should be true. So this whole thing is true. I screwed this up. Or I think Vincent screwed this. This should be a B and this should be an A. And then I should reverse these. Okay, hold on. I can fix this. I think I just need to do this. I think I tried to fix it, and in fact I broke it. Okay, so back to here. I know here that it is either the case that y is less than or equal to 0 or y is greater than 0. So this must be the case. This must mean, yeah. How have I, no, shiza, I had it right in the first place. Anyways, go home and try to figure this out. Oh, no, okay, no, I got it, right? One of these two conditions are true, and both of these conditions are true. So we have y is greater than or equal to 0, so this becomes true. Is x less than or equal to 100? I don't know if we can conclude that. This worked in the last class. I did record that one. So check out the recording for the last one. Anyways, this should, if this was done properly, this should have all become return A, right? In which case, I just would have replaced everything by return A, and you guys would have went, whoa, that was so well done without error. Anyways, I'll see you guys on Friday, yeah? And I have office hours today if anyone's looking for me. Yeah. No clapping. Yeah.